Mr. Harris here, and welcome to a new video of Chapter 9.4. In this video, we're going to talk about the effects of acids on metals. So over here in the diagram, maybe some of you know what this is, especially Filipino students. This is a dish called sinigang. I'm not sure whether I'm pronouncing it right, so maybe you guys can help me verify it and let me know. So this dish is famous for having steamed rice, vegetables, meat, and sometimes seafood. But what I'm concerned about is that they use a clay pot for cooking. A clay pot. And also, sometimes a small amount of vinegar is added during the cooking. Vinegar. That that looks like that looks like a smiley face. Okay, that's not what I intended. Let me do that. All right, you have vinegar. So what I'm concerned about is whether vinegar is an acidic substance or is it an alkaline substance. Yes, vinegar has a lot of acid. However, in some dishes, a lot of vinegar is added during the cooking. And in these type of dishes, melt pots are not being used. Instead, clay pots are. So now I have a question. Why can't we use melt pots when we're using vinegar? Now I can give you a hint. It has to do with the acid that is present. So is there some type of reaction between metals and the acid? Let's have a look. So in this experiment, we're going to see the reactions of dilute acid with some metals. Now I want you to pay attention to the four metals we're going to use: zinc, magnesium, iron, and copper. So first off, you get a test tube and add the dilute acid. Afterwards, you grab a pair of forceps. So this instrument is forceps. Then you put the piece of zinc inside the test tube. Afterwards, you cover the mouth of the test tube loosely. Not tight, okay? Loosely. With an inverted stopper. You may ask me, Mr. Harris, what's the big deal about having an inverted stopper? Now, first off, it's inverted. Inverted meaning it's upside down. Alright? Now, I want you to imagine you have a test tube over here and you have a very tight stopper. And there's a reaction going on. Now just imagine, for example, it's giving off a lot of heat, gas bubbles are produced. What would happen inside the test tube? Yes, a lot of pressure will be building up and eventually, boom, there'll be a huge, not huge, okay, but there'll still be an explosion. And we do not want that to happen in the lamp, right? So we cover it loosely and inverted. The reason behind is if there is indeed a gas being produced, this will move the stopper a bit. Still be a slight movement. So we'll be aware of this slight movement and we'll be paying attention to the experiment the whole way. So even if there is no reaction or there is a reaction, we'll still need to do one particular test. And this is using the burning splint. Now all of you should know, I've learned this, not I've learned this, you've learned this, I've also learned it of course. You've learned this in the topic of photosynthesis and respiration. This is a test for what type of gas? Yes, it is for hydrogen. So you put the burning split near the mouth of the test tube and you will hear a pop sound. So this confirms that a hydrogen gas is produced during the reaction. So we'll be doing the same steps for the other metals, magnesium, iron, and copper. So let's have a look at the results. Let's have a look at zinc and magnesium first. For both of them, gas bubbles are given off. In the test for hydrogen, they give a pop sound. So that confirms that hydrogen gas is produced. And one more thing. After the reaction, the appearance of the metal changes. They become smaller in size. Okay, they become smaller. And the reason behind it is because they're used up in the reaction. All right? Let's have a look at the other metals. Iron is the same. Gas bubbles are given off, burns with a pop sound, hydrogen gas is produced, and it becomes smaller in size. However, look at copper. No gas bubbles are produced, no sound is produced, no hydrogen is produced, and the size remains unchanged. So, what does this tell us? Copper has no reaction with the dilute acid. What can we conclude from this now? You can see some metals, they have reacted. However, in this case, copper metal did not react. So, to conclude, not all metals would have a reaction with dilute acids. Only some metals. So let me go ahead and write that down. Dilute hydrochloric acid reacts with some metals only, such as zinc, magnesium, and what was the other one? Iron. Not copper, okay? There's no reaction with copper. During the reaction, what gas was produced? Hydrogen gas. Yep. Oh. And the metals do they become smaller in size or larger? They become smaller in size. All right. So now let's go back to the original question. So the original diagram that I showed you was actually a diagram of pork knuckles and ginger stew. This is a traditional Chinese dish. Usually they add a lot of vinegar inside this dish. And as we know, in vinegar there is acid, and we avoid using metal pots. The reason behind is because the metal could react with the acid. And as we all know in chapter 9.1, I've taught you that acids are corrosive. So we do not want any of that acid to be present in our food. All right? So just to give you a quick cooking tip, I know all of you will be now at home doing your assignments, watching these videos. Of course, some of you will be helping your parents as well, so I'm giving you a quick tip. Never use a metal pan when a large amount of vinegar is involved. All right, so you can let your parents know. If they use a large amount of vinegar in their cooking, you can tell them, Daddy, Mommy, do not use a metal pan. All right, let's come back. Dilute acids, they could corrode some metals, not all. And when dilute acids react with metals, hydrogen is produced and a salt is as well. Now, this part, let's have a look. How do I know a salt is produced? Because we have our favorite word equations over here. So the word equation, metal plus acid, you get salt plus hydrogen. Just to recall, the left part of the equation, these are the reactants. And the right part of the equation, these are the products. Now you'll notice one thing, it is very similar to the word equation of neutralization. Do you remember the word equation of neutralization? Let me write it down. So neutralize. Okay, I'm just going to put neut. You got alkali plus acid. You would get salt plus water. So you would notice both of these word equations are very similar. Another very similar thing between these two word equations is the type of salt that you get is it would depend on the type of acid and metal that would react. So it's very similar to neutralization. What do I mean? Let's have a look. Let's see some examples. So you have zinc metal over here on the left and hydrochloric acid. These two would react to form zinc chloride salt and hydrogen gas. So do you recall how we need to name salts? How I've taught you the way to name salts? So first step is you get the first name of the salt, and you can get it from the first name of the metal, just like how for neutralization you get it from the first name of the alkali. And then you get the acid, hydrochloric acid in this case, so you get the name from the first name of the acid, chloride. Same thing over here. Iron plus sulfuric acid, you get iron sulfate plus hydrogen. So you get the first name of the salt, you would get it from the metal. And then the second name of the salt, sulfate, you can get from the first name of the acid, sulfuric. All right. So just to summarize what we've learned in this video, so I've taught you about how some metals are able to react with dilute acids, not all. I gave you a quick cooking tip. You can let your parents know about that. And just now we've learned about the word equation. All right, so that's the end of this video. I'll see you in the next one. Bye for now.